The first step is to check the minimum and maximum longitudinal reinforcement for the columns. According to Section 18.7 of the ACI Code 2019 version, which covers longitudinal reinforcement for special moment frame columns, the reinforcement ratio should be between 1% and 6%. There are two common methods for splicing longitudinal reinforcement: mechanical coupling splices and lapping splices. For this project, we'll assume we are using the lapping splice method. We need to respect the maximum reinforcement limit at splice locations. If all the bars are spliced in one spot, the reinforcement ratio in that zone should be limited to 6%, which means the ratio outside the splice zone should be 3%. Therefore, we must ensure that the maximum longitudinal reinforcement calculated by ETABS doesn't exceed 3%. Now let's go to ETABS. From Design menu, we click on Concrete Frame Design, and then Display Design Info. In this window, we choose Total Rebar Percentage and click OK. To view the column reinforcement percentage more clearly, we'll hide the beams. I'll click on the Set View Options icon and uncheck the beam box. Now we'll go through the elevations of the structure. To make sure that the longitudinal reinforcement percentage doesn't exceed 3%. But since it's difficult to manually check every column by eye, here what we'll do. To check the maximum value of longitudinal reinforcement in the columns, we go to the Model Explorer, switch to Tables tab, then navigate to Design Data, and click on Concrete Frame Design Output. After that, we go on Concrete Frame Detail Data. Right-click on the Concrete Column PMM Envelope and select Show Table. In the PMM ratio or rebar column, you'll see that the calculated longitudinal reinforcement percentage. If we click on Sort Descending, the percentage will be arranged from highest to lowest. As you can see, we need to reduce the percentage that are over 3% and increase the dimensions of these columns to lower their longitudinal reinforcement needs.